Well, hello everybody, Mr. Reeves back with you again today. And today we're going to look at probabilities involving OR. So hopefully you had a chance to do some learning on probabilities of compound events. In the probability of compound events, we were looking at probabilities involving and. And you remember when we had more than one event occurring, we would take the probability of each event and we would multiply those probabilities together, and that would give us the total number of outcomes. Sorry, not the total number of outcomes. That would give us the probability based on the total number of outcomes. So when we use the word and, using compound events, we multiplied. Well, when you use the word or, things are a little bit different. So let's go ahead now and just dive right in and take a look at a couple different problems. All right, so if you take a look here, it says probabilities involving OR, and then it has this term mutually exclusive, and then it says not mutually exclusive. So before we do any problems, let's talk about what that means. So mutually exclusive events are events in this case that they don't overlap. There is no overlap of the events. If one occurs, the other one cannot occur. And if the second one occurs, the first one could not have occurred. All right? So for example, on a die, it says what is the probability of a 1 or a 3? Well, you can't have both those things happen at the same time, right? When you roll this die, you cannot get a 1 and a 3 at the same time. It is impossible. Those are mutually exclusive events. Another example would be tossing a coin. If you toss a coin, you can't get both a head and a tail at the same time. Those are mutually exclusive, right? Or if you were spinning a spinner that had the numbers 1 through 6, you couldn't get the number 1 and the number 3 at the same time. Those would be mutually exclusive. So mutually exclusive events are two events that cannot both occur at the same time. All right, so if we take a look at this problem right here, it says you're rolling this 6-sided die. What is the probability of getting a 1 or getting a 3? All right, so let's go ahead and take a look here. The probability of getting a 1 or of getting a 3. So if we look at the die, what are our outcomes here? Right? Well, if we roll that die, we could get a 1, we could get a 2, we could get a 3, we could get a 4, we could get a 5, or we could get a 6, right? And what are they saying? Well, we could get a 1, and that would be a winner, or we could get a 3, and that would be a winner. And as you know, probability is the number of desired outcomes over the number of total outcomes, right? That's what we're looking at. So if we look at our desired outcomes, our number of desired outcomes is a 1 or a 3, so there are 2 desired outcomes. And the total number of outcomes is 6. So the probability would be 2 out of 6, or if we simplified that, that would be 1 out of 3. Or if we wanted to write that as a percent, that would be 33 and 1/3% probability. All right, so that's how you would do it by looking at the outcomes. But what about if we just looked at the probabilities separately? What is the probability of getting a 1? Well, the probability of getting a 1 is a 1 out of 6, right? And the probability of getting a 3 is also a 1 out of 6. And since these are mutually exclusive, I can add them. So if we have mutually exclusive events, the probability of A plus the probability of B will give us the total probability. All right. So in other words, that's the probability of A or B, right? So here we go. So the probability of A is 1/6, and the probability of B is 1/6. Well, 1/6 plus 1/6 is 2/6, right? There they are. This one, there's one of those. There's one of those. Both of them have out of a list of 6. So 2 out of 6 is 1/3 or 33 and 1/3%. So up here, I showed how to get the result just by listing out the outcomes. And here is a formula type of way. The probability of A plus the probability of B, assuming again that these are mutually exclusive events, the probability of A plus the probability of B will give you the probability of A or B, again, if these events are mutually exclusive, meaning they both cannot happen at the same time. Okay? So that's how you do mutually exclusive problems. All right, what if they are not mutually exclusive? Well, let's talk about what not mutually exclusive means. All right, so here we have a spinner, and the spinner has the numbers 2, 3, 4, and 5, right? Okay, so if we look at the outcomes, right? The outcomes are we could get a 2, we could get a 3, we could get a 4, or we could get a 5. Those are the outcomes, correct? One of those 4 things will occur. Now, the probability that it's a 2, the probability that it's a 2 is right here, right? So the probability that it's a 2 is 1 out of 4. Do you agree? 1 out of 4. And then the probability that it's less than a 5. The probability that it's less than 5. Well, if we look at the probability that it's less than 5, well, 5 is not less than 5, right? But 4 is less than 5. 3 is less than 5, and do you agree that 2 is also less than 5, right? Well, what do you notice about these colored circles? Number 2 is circled by both, right? So 2 occurs here, and 2 occurs here. By the way, the probability that it's less than 5 would be 3 out of 4, right? So if we did what we did before and we added these together, 1/4 plus 3/4 would be 4/4, which would say our probability was 1, or we had 100% chance, 100% chance of getting a 2 or 5. But as you could see, 5 is not circled by either of them, is it? All right. So if we're going to look at these probabilities, we can't just add them together, can we? We have to take away the one that overlaps. So if I spin, which of these would be a winner? How many would be a winner? If I got a 4, is it a winner? Yes. If I got a 3, is it a winner? Yes. If I got a 2, is it a winner? Absolutely, right? So the probability of getting a 2 or less than 5, which ones are my winners? 3 out of 4, right? So I have a 3 out of 4. Remember, what is probability? It's the number of winning outcomes, right? Over the total number of outcomes. So if we take a look at here, how many are winners? 3 of them are winners, right? Now if you're going, well, wait, 2 wins twice. Right, but you can't land on 2 twice when you only spin once. So if you land on 2, you're a winner both times, right? So 3 winners out of 4. So the probability that we're looking for is 3/4, which is the same as 75%. All right, but what about the formula? What would we do here? There's got to be a formula way, right? So if they are not mutually exclusive, if we're talking not mutually exclusive, then what do we get when we do the probability of A or B? Well, the probability of A or B, guess what we're going to do? We're going to do the probability of A plus the probability of B, but we're going to subtract what I'm going to call the overlap probability. Probability, right? All right, so the overlap probability, what is that overlap probability? That's the one that occurs more than once, right? Okay, so the probability of getting a 2 was 1 out of 4, right? And the probability of getting a number less than 5 was 3 out of 4. But how many overlapped? How many were circled in both colors? 1 out of 4, right? So we have these two added together, right? That's just like we did when they were mutually exclusive. And when you add those together, you get 4 out of 4, like we said earlier. Well, that would guarantee you a win, right? But what are we going to do? We're going to take away that overlap one, and that gets us back to 3 out of 4, or 75%. All right, so if you're thinking, well, that's kind of silly, we already had the answer, why not just do it this way? You know what? It's a really great idea anytime you're working with probabilities, if you have a reasonable number of outcomes, to list the number of outcomes and choose from there. But there are those people who always need a formula. So this right here would be the formula. Either way, there are 3 winners out of 4 outcomes for a probability of 3/4 or 75%. All right, so let's go ahead and dive in and look at some examples here now that we've got the theory and we looked at a couple there. All right, so let's take a look. You pick a card at random. 1, 2, 3, 4. We have 4 possible outcomes. What is the probability that it is even or greater than 3? So I'm going to do like I just did. I'm going to go ahead and list my outcomes here, right? And what are my outcomes? My outcomes are 1, a 2, a 3, or a 4. All right, so let's take a look at this first one right here. What is the probability that it is even? Well, is 1 an even number? No, sir. No, ma'am. Is 2 an even number? Yes, and 4 is an even number. So the probability that it's even is 2 out of 4, or 1/2, right? Okay, so now let's take a look at the next one. So what is the probability that it is greater than 3? Probability that it is greater than 3. All right, well, which ones are greater than 3? Is 1, is 2, is 3, is 4? Nope. Only 4 is greater than 3, right? So that probability is 1 out of 4. Now, let me ask you a question. Is this mutually exclusive, or is this not mutually exclusive? And the way to know is part of your outcome list circled more than once? And as you could see, 4 clearly is circled twice, because 4 is even, so it satisfies this purple probability, right? And 4 is greater than 3, so it satisfies this red probability, so it's circled both times, right? Okay, so it's very good to know. Now, if you're just going to do the counting method of probability, how many winners do we have? Remember, because probability is the number of favorable outcomes, right? The number of favorable outcomes over what? Over the total number of outcomes. total number of, let's try to get this right, Mr. Reeves, outcomes. All right, so here we go. So the number of favorable outcomes was 2, right? The number of total outcomes was 4. And so we have a 1 out of 2, or a 50% chance. All right, if we did it the formula way over here, the probability of an even would be 1/2, and the probability of greater than would be 1/4. But then remember, we have to subtract that overlap. Well, the overlap is 1 out of 4, right? So we get a half plus a fourth minus a fourth. Well, I'm not even going to add those together. I'm just going to cancel those. And that gives us our probability of 1/2, or 50% as well, right? So we're going to go ahead and say that the answer is 50. And we are brilliant. Okay. I'm feeling confident now because iExcel just told me I was brilliant. Okay, so we're spinning the spinner once. What is the probability of a 4 or a 5? All right, so again, if we look at our outcomes, right? Our possible outcomes are 3, 4, 5, and 6. So we have 4 possible outcomes. And we want to know what is the probability of a 4, or what is the probability of a 5. Well, if we take a look, the probability of a 4, there's a 4. How many 4s are there? 1 4. Out of how many total outcomes are there? 4. All right, what is the probability of a 5? There is 1 5. Out of how many total outcomes are there? 4. All right, now let's ask ourselves, is this a mutually exclusive event? So when we look at our outcomes, did we circle anything twice? And the answer is no, we didn't circle anything twice, right? 4 is circled in purple. 5 is circled in red. All right, so what is our probability of getting a 4 or a 5? Well, how many winning choices, how many favorable outcomes do we have? We have 2 of them out of total 4. So we get 1 out of 2, or 50% again, right? All right, if we were going to use the formula way, right, since it is mutually exclusive, the probability of the probability of getting A or B, right, is equal to the probability of A plus the probability of B. If they are mutually exclusive, if there's no way the two things can both happen at the same time, we can add those together. And when you add a fourth plus a fourth, 1/4 plus 1/4 is equal to 1/2, which is 50%. So we can write our answer as a fraction or as a whole number. In this case, we got a half. Okay, so let's just talk through this right here. You flip a coin. What is the probability of tails or heads? All right, is it mutually exclusive? Can you get a tails and heads at the same time? No. What's probability of getting a heads? A half. What's probability of getting tails? A half. So what's the probability of getting either a head or a tail? This would be a great game to play because you would always win, right? No matter what side of the coin it lands on, you are a winner. All right, what about this? We're rolling a 6-sided die. What is the probability that it is a 3 or that it is odd? Okay, so if we look at this one, this would be a little more complicated. Better write this one down. This is the last one we're going to do here in this video, okay? All right, so we want to know the probability that it's 3 or odd. So let's go ahead and look at the total number of outcomes, right? Our outcomes are 1, 2, 3, 4, 5, and 6. So let's take a look at the probability of getting a 3. Well, how many 3s are there? There's 1 3, right? Out of how many total outcomes are there? 6. So the probability of getting that 3 is 1 out of 6. All right, so what about the probability of getting an odd number, right? Odd numbers. Well, odd numbers 1, 3, and 5, right? So the probability of getting an odd number is 3 out of 6, or if we simplify that down, that would be 1/2. Well, what do you notice when you look at this list? The number 3 is circled twice. That means that this is overlapping or not mutually exclusive, right? So again, I think the easiest thing to do in this situation is just to count. How many are circled? How many are winners? 3 are winners out of 6, right? Now, if you're going, well, wait, that 3 is a winner twice. Absolutely, it's a winner twice, but you can only land on it once, right? You win on this, you lose on this. You win on this, you lose on this. You win on this, you lose on that. So you have a 3 out of 6 chance, or 1/2, or 50% chance of winning if you had to get a 3 or an odd. And again, if we were doing it over here, we would add the 1/6 to the 3/6, but then we would just turn right around and subtract that 1/6 away again, and we would get 4/6 minus 1/6 is 3 out of 6, which is 1 out of 2, or 50%. But again, guys, when they overlap, I think just looking at the outcomes, unless you have a crazy number of outcomes that's too big to list, which none of these problems are going to be, just listing out the outcomes, finding the total number of winners, that's, in my opinion, the best way to go. All right, so just to make us happy, let's go ahead and this time let's put it in as 50% just for fun. And, oh, they don't like it. Because I didn't put the percent symbol. Oh, well, 50% is what I meant. Let's see, do they have 50% down here? No, just a half. Well, there you go. Now you know if you're going to put in a percent, you got to put the percent symbol. Shame on me, I should have known that. Alrighty, well, I hope this video was helpful, except this mistake at the end. Have a great day, everybody.